All right, last unit test of the year. So by the time you're done with this, I mean, you've essentially learned all the second semester stuff, all the second semester material, and this is really the last regular test. Plus, you have your exam, obviously, but most of you, by the time this test is done, will be in a position to where you pass second semester. Some of you won't be, but that's okay. You'll have the exam. But this is the um, last bit of new material to be tested on. Some might need retakes, some won't, but what I'm trying to get at is you're almost done, but don't slack because you're almost done. Let's sprint through the finish line, play to the whistle, as soccer players would say. A lot of people would say hockey, wrestling, basketball, track runners, the big track weekend. So I'm thinking sprint through the finish. Um, let's do it. Let's get the slides going. Oop, sorry. Okay, let's figure out the period here. How are we going to figure out the period? We got x over 4. Remember, that's like saying 1/4 x. So you're going to take your regular pi of 2, your regular period of 2 pi, divide that by 1/4, which is like saying 2 pi over 1 times 4 over 1, the reciprocal, right? Because we keep change flip 2 times 4, 8 pi over 1. So letter C. Just because you have a multiple choice question doesn't mean you don't show work, right? Do all that work so that your choice that you take is an informed decision. The period for the function 3 sine 2x, again, you got this 2 hanging out. We're going to take our regular period, divide it by 2, 2 divided by 2. You just got the pi left. It's your period. That means your whole wave would take 1 pi to complete a rotation. All right. When we look at the amplitude and the midline here, the amplitude, think about the amplitude. The amplitude is not from the top to the bottom. It's half of from the top to the bottom. So amplitude goes in both directions. It's saying you're going to go 5 up and 5 down. Essentially, if you have an amplitude of 5, you're saying that it's 10 spaces between the top and the bottom. And then your midline is what's in the middle there. So let's look at this first one, A. It's at -2 on the bottom. On the top is 8. So if this took 2 to get up and then went up 8 more, 8 plus 2 is 10. Dividing that by 2, and you have 5. That's the amplitude we're looking for, right? It's the only one that is that big. 8 to 2 is just 6. We don't want 6. 6 divided by 2 would be the amplitude there. Here from 5 to 1. So that's not what we want. So basically what we're saying is if your amplitude to take the space from the top to the bottom, cut it in half. And then you take that amplitude to figure out the midline. So the amplitude here is 5, and it's the only one with an amplitude of 5, so essentially can move on. But why is the midline 3? Well, if you went from 8, right, down to, if you went down 5, 8 minus 5, you would land at, should keep going a little bit, a midline of y equals 3. So we kind of prove, by finding that amplitude, you can prove where the midline is. All right. Keep flipping on this because the bar on mine is kind of blocking. You guys can't see it, but it's making my screen a little tough to see. So apologies for the speed there, for the delays in some of these answers. All right, the equation of the midline. All right, so I don't know, this one was kind of tough to see on your paper, but if we have 7 here and 3. So 7 down to negative 3. So again, we're in a position where we've gone 10 spaces. Okay, so why am I doing all that to figure out the midline? Because eyeballing this, I don't think is going to be great because you can easily make you might get it right by just looking and seeing exactly what the middle is. But if I look at this and I say, okay, 7 to negative 3 is 10. So let's think my amplitude of this function, 10 divided by 2 is going to be 5. So how do I get to the midline? Well, I need to go from 7 down 5, which lands me at a midline of y equals negative 2. And for me, for whatever reason, it doesn't look like 2 is physically the middle when I just look at it right away. Maybe your guys' eyes are better than mine or your sense of this. So I got to do some math to actually get that, especially when there's dashes there and it wasn't a very well printed graph. So I got to go from the top, find myself the amplitude, and get to that middle. Period of the function, a little more straightforward. Period, you just have to see, the period is asking how long does it take for one full wave to happen? So this is half a wave. It took 2 pi for half a wave to happen. That full wave from left to right, how long did that take? It took 4 pi. Okay, from here to here was 4 pi. And it checks out because look, there's 2 waves here. 2 waves, and it took 8 pi. So the period of the function, 4. Excuse me. I didn't love this one because, gosh, it essentially looks like it's really close to 0, but not quite there. Just, you know what? I didn't love that. So I just made this in my head go all the way to 0 because it's not a good enough fraction or decimal to where we could even estimate there. It's gonna be like 0.1 or zero point 0.2 or something. So I just say, okay, we ran into the ground here. We went to 0. And I didn't love it up here because look, we've got like 5 would be right about here. So the peak is, I guess we could say that's 4.5. That wasn't as bad. All right, so why do I need to know those things? Well, the bottom and the top, if I'm going to figure out the midline, I need to figure out the amplitude because from the top to the bottom, if that's 4.5, to figure out the amplitude, I need to take 4.5, cut it in half. That's going to give me 2.25. And in this case, if I go from the bottom, sometimes go from the top to the bottom, other times, or top to the middle, other times bottom to the middle. I think for whatever reason, adding from 0, going up 2.25, the amplitude. 3 is here, then 2.5. So 2.25 would be right about there. So the midline, I would say, is about y equals 2.25. So it kind of works out here that they're the same thing. And if you forgot how to do them, if you had a 50-50 shot on this. Okay, so something a little easier about this was the period, but even that was a little off. Like, where did we exactly start? But it looks like about one wave is about 12 hours. Might accept 13 hours there, 12 and a half, but it essentially takes, switch colors. Just think if you're at the bottom here at 6, when do I get back to the bottom? Roughly at about 18, right? So there's about 12 hours between a full wave. Or if you just went from the beginning, so I don't love that because it's like not quite to the peak, 0 to 12 to get to that full wave. All right, I gotta move my. All right, there's a few things I want to make note of before I start graphing this. Okay. Um, amplitude is just given to you. It's right here. What's the amplitude? It's 3 because it says 3 right there. So the amplitude is 3. The midline also given to you, -2. So there's your midline. Y equals -2. Period, you got to work for. There's nothing there. So it's essentially saying 2 pi divided by 1, not divided by 0, divided by 1. So your period remains 2 pi. All right, your maximum, that's your midline plus your amplitude. So -2 plus 3 gives you 1. Your minimum, -2 minus your amplitude, you'll be down in the -5 area. Okay, so a lot of people like are mixing up the max and min because they can't remember like which one are you adding, which one are you subtracting, especially when there's a negative involved. Okay, you're overthinking it. Okay, the maximum needs to be higher than the minimum. The maximum you need to go up from the middle to get there. The minimum you need to go down from the middle to get there. All right, we have a sine wave here. What does a sine wave tell me? It tells me that we're going to start in middle and go up. All right, so at 0, I've started. What is the middle? The middle is -2. So let's label these 1, 2, 3, 4, 5. All right, so if I start in the middle, it's -2. Let's get a different color. Start in the middle. And then I'm going to go up to the maximum. The maximum is +1. And then I need to come back down, back to the middle, then down to the bottom, and back to the middle. And so I've done these 4 main points. I haven't labeled my x-axis yet because I've drawn the entire wave, and then I can realize, okay, how long did it take for me to do that entire thing? Well, it took me 2 pi, which means half of that would be pi. Half of that is pi over 2. I know that can get real messy. I saw someone do this on one of the tests a couple times ago, and that is label their x-axis down below, and that's fine by me because then you got a little more room. So we got 2 pi, pi, pi over 2. Three pi over 2. And if you end up saying pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is the same as 2 pi. If you do that, I'm fine with it. We want to just make sure we get our intervals correct. And it kind of helps when you're moving on to the next wave, the next cycle of the wave, I should say. Next cycle of the wave. Right, so if we had 4 pi over 2, this would be 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, aka 4 pi to get 2 cycles. Okay, let's do this again. My amplitude right there, 2, midline right there. That line is so mid. Y equals 1. My period, I'm going to use this 2 to get my period, which is 2 pi divided by 2. 2 divided by 2, cancel out. Got a pi. Maximum, you're going to take that midline and add the amplitude. The minimum, you're going to take the midline and subtract the amplitude. Okay. This is a cosine wave. What do I know about cosine? Cosine starts at top. Start top. Go down. All right, so we got 1, 2, 3, 4, -1, -2, -4. All right, it says start at the top, and I said that the top, aka the maximum, is 3. So go up to 3. Let's get a different color when we're graphing. Okay. We said the middle was 1, so I'm going to go down to 1. Said the minimum is -1, so then I go down to -1. And then back in that same order. So there's my 1 full wave. And then middle, bottom, middle, top. And I have 2 full waves. Okay, if this entire wave was pi, then half of that was pi over 2. And before that, half of pi over 2 is pi over 4. So you got 1 pi over 4, 2 pi over 4, aka 1/2 pi. You got 3 pi. And so on. All right, the famous or infamous, depending on your perspective. Did I miss a graph? No, I got it. All right. The famous Ferris wheel. How tall is the Ferris wheel? Well, let's look at the middle. Add the amplitude. And you've got an 80-foot Ferris wheel. All right, so there's the middle. The amplitude. You add the middle and think of the amplitude as the arm size, go from the middle to the top, and you get the height. Showing that work, 50 plus 30. Don't just write 80. If you write 80, I need to see how you got 80. How long does it take to complete 1 full rotation? So you got your regular period of 2 pi. You're dividing by, you got pi over 4. Dividing by fractions is going to be tough. So I say, hey, do 2 pi over 1. Multiply instead of divide. Flip pi over 4 to 4 over pi. 2 times 4 is 8. 1 times pi is pi. Pi on the top and the bottom cancel out. We're talking in minutes here, so your period is 8 minutes. Might seem like a bunch of just weird math to get there, but essentially this is saying it's going to take you 8 minutes to ride this around this entire Ferris wheel. Okay. Now we've kind of given you a little bit of help here. We use the amplitude there of 30 and a midline of 50 in the period of 8 minutes. Got to keep this maximum in mind. Think that it's 80. And if you took that 30 away from 20, 50, 30 away from 20. If you took that 30 away from 50, you would get a minimum of 20 feet. Okay, so when we're measuring our time, we're going to be measuring it in minutes. I did 1, 2, 4 spaces at first because I need to think, hey, I need to get 8 minutes to get the full thing, 4 minutes to get half, and everything should be counted in half of that because I need to get that fourth of intervals every time. All right, now I need to measure my, I'm getting better writing sideways. Height, we're measuring in feet. Oh, just as I say that, I forget to write it sideways there. Okay, so we're going to go 20, 40, 60. Got a bonus question at the end, so stick around for the whole thing because I want you to talk to me. This is how I know whether you've done this, whether you're listening to me or if you're just writing what I'm writing on a screen. Come up to me and tell me something here at the end. But first of all, we're going to look at this negative cosine wave. This negative cosine wave means you're going to get your Drake on. You're going to start at bottom. And you're going to go up, start around on bottom. Yeah. All right, because it's negative cosine. Start at the bottom and go up. So what was the bottom? We said it was 20 feet. So that's where we're going to start. Start at 20 feet. Then we go to the middle. The middle was given to us. It was 50. We go to the top. We calculated it. We worked hard to calculate it. Now let's use it. It takes us 4 minutes to get to the top of that ride, which means it's going to take us 4 more minutes to get back down to the bottom. So after 8 minutes, you've gone around this entire Ferris wheel. Do another cycle. And then the bonus question at the end, I want you to approximate. I'm not even going to show it. I'm going to ask you to do it. I want you to approximate when does the Ferris wheel reach 60 feet? Give me multiple times that the Ferris wheel will be at 60 feet. So when, let me write it in a separate color. When will Ferris wheel be 60 feet off the ground? That's what you're going to stop me in class and tell me. Okay, use the graph to figure that out. All right, last unit test, I should say. You also have your exam and possible retakes, but almost done. All right, I'll stop the share. Now let's stop the recording. Bye, everyone.